Welcome to EDU World Space.
We'll be looking at how to determine a moment due to the action of a force in a Cartesian system. Let's say we have a force F equal 50I minus 20J minus 80K Newton. And this force is causing moment about line BC. And the coordinates are there already for B, C, and D. Now, what we can do to find the moment, that moment, is to look for BC, the unit vector BC, and the vector CD, and multiply them with this force to get our moment, so that M is equal to U unit vector BC times CD, okay, times force. All right, but BC, how do we get BC? BC is actually C minus D. Now, all the positions are there already. So if you bring out the different vector components, you are going to have your CD to be equal to, sorry, C minus B, not C. It's C minus B. So you're going to have the various components to be minus 1.5 I minus 2.5 J plus 0K. That's what your BC will give you. And of course, you look for the magnitude of BC. When you look for the magnitude of BC, you solve it out, you're going to have it to be 2.92. All the components, just square them, and add them, and take their square root to get that one. Then how do you now get your BC? Now your BC now is, sorry, your unit vector now, your UBC now, is actually equal to your BC that you have gotten over the magnitude BC. So that when you solve it out, you're going to actually have it to be minus 0.5 ij 1 ji minus 0.86 j plus 0. Okay. They follow the same process to get your CD. The way since we know the position of C and D, to get our CD is going to give us actually D minus C. Bring out the various components of it and solve it out. You are going to have it to be 0.515 I plus 2J plus 4K. So you cannot bring them into the matrix equation, into the metric system. To do that, you are going to have your M to be equal to something like this. For the unit vector is minus 0.51. Of course, we have the minus 0.86 and 0. Then for CD, 0.5, 2, 4. Of course, we know the force is 50 minus 20 minus 80. So when you solve out using determinant to solve it out, you're going to have your answer will be equal to minus 165.6 Newton meters.